Hi, I'm Carrie Johnson. I am in the business of interpreting ancient landscapes and thinking about how and why they change through time. I use a variety of basin analysis techniques to do that. In theory, we would like to think of sedimentary basins as the ultimate sink in our sediment routing system from source to sink. And we go to sleep at night praying that they are faithful recorders of, at least at a first order, major signals and controls on that are acting on this entire system. So I don't have a song, but I will entertain audience participation if you cooperate. When you think about first order controls on sedimentary basin fill, just what are the primary signals that you would hope to be preserved in the sedimentary record? What sorts of things come to mind? On the count of three, shout it out. 1, 2, 3. Tectonics. And where's my group? Sea level, you guys. Climate tectonics and use to sea. That's kind of the holy trinity. A trend in the field, though, is towards a more sophisticated view of how and if those signals are really propagated and preserved, and we talk about signal shredding, partly thanks to autogenics. So this refers to the natural self-organization behavior of depositional systems. Rivers avulse across their floodplain, they do that naturally. Delta lobes switch back and forth. You don't have to perturb the system to make that happen, but external controls can make that happen. And so what we talk about now is the idea of signal shredding, which is that these other factors can obliterate completely, in some cases, these original signals. We are dealing with the rock record, meaning that half of our puzzle pieces are basically missing. And so we're kind of left with this. And that is a very bleak view of modern basin analysis. Now that I think about it. So on the positive side, we have a lot of smart people tackling these kinds of questions. So my group addresses these problems from mainly a modeling perspective, but modeling broadly defined. We work on conceptual models of decades-old sediment in Lake Powell river deltas. We work in deep time and petroleum systems modeling. We create digital outcrop models using a drone in South Africa and in Utah. We do a lot of work in source-to-sink modeling using provenance techniques. And that includes the old standard detrital zircon, uranium lead geochronology, working in Diego's lab for that. But we're also starting to do some work on common lead isotopes and tetridyl potassium feldspars to fit into the mix. Pete mentioned last time that we're moving back to Mongolia, yay, so there will be some new Asian tectonic models coming into play as well. The sum of all this is that we work all over the world on rocks of lots of different ages. Undergrads, there's room at the table. If you would like to get involved, please come talk to me.